Begin by verifying the wiring diagram. Refer to a reliable wiring diagram for a three-way switch setup to ensure proper identification of the wires. Secondly, check for continuity. Use a multimeter to ensure continuity between the two 12.2 cables coming out of the wall, verifying a proper connection. Thirdly, identify the traveler wires. These wires connect the two three-way switches. A multimeter can help identify them. They should exhibit continuity with each other when one three-way switch is on, and continuity with the other two wires, power and common, when the other switch is on. Fourthly, check the switch terminals. Ensure the hot wire is connected to the correct terminal on the three-way switch. It should connect to the common terminal. The traveler wires should connect to the remaining two terminals. Fifthly, check for a faulty switch. If other steps fail, consider replacing the three-way switch. The existing switch might be faulty and not functioning correctly. If the wiring diagram is correct, try changing the wire connections to the three-way switch by connecting the traveler wires to the other two terminals. Double-check the connections and ensure the traveler wires connect to the correct terminals on the switch, especially if attempting a reverse switch loop. Verify that the hot wire connects to the common terminal on the three-way switch and not to the traveler terminals. If unable to resolve the issue, it is recommended to contact a qualified electrician for assistance. Remember that electrical work can be dangerous, and it is important to take all necessary precautions. Always turn off the power at the circuit breaker before working on any electrical wiring. Wear appropriate safety gear, such as gloves and eye protection. If you are not comfortable working with electricity, it is best to call a qualified electrician. Understanding three-way switch wiring can be simplified by considering the basic function. A three-way switch allows a light or other electrical load to be controlled from two different locations. This is commonly used in hallways, stairwells, and large rooms where it is convenient to have a switch at both ends of the space. The key to understanding three-way switch wiring is to recognize that neither switch directly controls the power to the light. Instead, each switch controls which of the two traveler wires carries the current. The common terminal on each switch is the one that is either connected to the power source for the light fixture. When the switch is in one position, the common terminal is connected to one of the traveler wires. When the switch is in the other position, the common terminal is connected to the other traveler wire. The two traveler wires run between the two switches. At the light fixture, the common terminal of one of the switches is connected to the power source, and the common terminal of the other switch is connected to the light fixture. When both switches are in the same position, the circuit is complete and the light is on. When either switch is flipped, the circuit is broken and the light is off. Let's delve deeper into how to troubleshoot a three-way switch problem with no power. The absence of power at the switch location itself suggests a break in the circuit that precedes the switch, or an incorrect wiring configuration preventing power from reaching the switch. Firstly, confirm the power source. The power source feeding the circuit needs to be verified as active. Use a non-contact voltage tester or multimeter to ensure that the incoming hot wire to the first switch location is energized. If there is no power at the source, the problem lies upstream, possibly a tripped circuit breaker, a loose connection in the panel, or a problem with the wiring leading to the first switch. Secondly, inspect the neutral wire. While the focus is often on the hot wire, a loose or disconnected neutral wire can also cause lack of power at the switch. Ensure the neutral wire is securely connected at all points in the circuit, including the light fixture and any junction boxes. Thirdly, examine the switch connections. Assuming the power source is confirmed, the next step is to carefully examine the switch connections. With the power off, check that all wires are securely connected to the switch terminals. Loose connections can prevent the flow of electricity and result in a lack of power. Pay close attention to the common terminal, as this is the point where the hot wire should enter the first switch. Fourthly, continuity testing is vital. Use a multimeter to perform continuity tests on the wires leading to the switch. Disconnect the wires from the switch terminals and check for continuity between the hot wire and the neutral wire. There should be no continuity, as this would indicate a short circuit. Also, check for continuity between the traveler wires. With the switches in different positions, there should be continuity between one of the traveler wires and the common terminal. Fifthly, identify misidentified wires. It's possible that wires have been misidentified, especially if the original wiring was not done correctly. Use a multimeter to trace the wires back to their source and ensure they are connected to the correct terminals. A wire tracer can be helpful in this process. Sixthly, check for hidden junction boxes. In some cases, there may be hidden junction boxes in the wall or ceiling that contain wire splices. These junction boxes can be a source of problems if the connections are loose or corroded. Look for any signs of a hidden junction box, such as a blank plate on the wall or ceiling. Seventhly, consider the reverse switch loop. In a reverse switch loop configuration, the power runs to the light fixture first and then to one of the switches. If you are trying to wire a three-way switch in a reverse switch loop, you will need to identify the wire that carries the power from the light fixture to the switch. Eighthly, address the light fixture issues. Although the problem appears to be at the switch, the light fixture itself could be the source of the issue. Check the connections at the light fixture to ensure they are secure. Also, check the bulb to make sure it is not burned out. Ninthly, dealing with multiple switches. If there are more than two three-way switches in the circuit, the wiring can be more complex. In this case, you will need to identify the four-way switches and the three-way switches. Four-way switches have 4 terminals and are used to control the light from multiple locations. Tenthly, document before disconnecting. Before disconnecting any wires, take photos or draw a diagram of the existing wiring configuration. This will help you to reconnect the wires correctly if you get confused. Remember to work safely and follow all electrical codes. If you are not comfortable working with electricity, it is best to call a qualified electrician. Here is some additional information about three-way switches. A three-way switch is a single-pole double-throw SPDT switch. This means that it has one common terminal and 2 traveler terminals. The common terminal is connected to either one of the traveler terminals depending on the position of the switch. The traveler terminals are connected to the traveler wires, which run between the 2 switches. When the 2 switches are in the same position, the circuit is complete and the light is on. When either switch is flipped, the circuit is broken and the light is off. The common terminal on the first switch is connected to the power source. The common terminal on the second switch is connected to the light fixture. The traveler wires run between the 2 switches. When the 2 switches are in the same position, the power flows from the power source to the first switch, through the traveler wires to the second switch, and then to the light fixture. When either switch is flipped, the circuit is broken and the power is interrupted. Three-way switches are commonly used in hallways, stairwells, and large rooms where it is convenient to have a switch at both ends of the space. They can also be used to control other electrical loads, such as fans and appliances. When wiring a three-way switch, it is important to identify the common terminal and the traveler terminals. The common terminal is usually marked with a screw that is a different color than the other screws. The traveler terminals are usually marked with the letters tone and T2. It is also important to use the correct gauge of wire. The gauge of wire should be appropriate for the amperage of the circuit. If you are not sure what gauge of wire to use, consult a qualified electrician. When connecting the wires to the switch terminals, make sure that the connections are tight and secure. Loose connections can cause problems with the circuit. After wiring the switch, test it to make sure that it is working properly. Flip the switch to both positions and make sure that the light turns on and off as expected. If the switch is not working properly, check the wiring to make sure that everything is connected correctly. If you are still having problems, consult a qualified electrician. Remember to always turn off the power before working on any electrical wiring. Electrical work can be dangerous, and it is important to take all necessary precautions.